So what we're going to do today is a quick practice on evaluating limits. So let's take a look at our first example. Let's say we have finding the limit as x approaches 3, finding the limit of x squared minus 9 over x minus 3. So as you already know, you've probably evaluated limits just by direct substitution. So if we were to substitute in 3 into the denominator and 3 in for the x in the numerator, we would get 9 minus 9 over 3 minus 3, which is 0 over 0. Well, that's not good. Doesn't work for us because that's called one of our indeterminate forms, right? So I'll write down all of the indeterminate forms really quickly. All right, so 0 over 0 is one of them, which we just see right above, which we don't like, we don't want. Another one you may come across is infinity over infinity. You may come across another one such as infinity minus infinity. There may be one 0 to the 0 power, 1 raised to the infinity, infinity to the 0, and 0 times infinity, right? So these are the indeterminate forms that we would want to be aware of. And when we come across them, we'll say, okay, we can't do direct substitution then. So in writing the problem over, the limit as x approaches 3 of x squared minus 9 over x minus 3, we have to go ahead and try to factor. So we would factor that difference of two squares. So we would get the limit as x approaches 3 of x plus 3, x minus 3, right? Not too bad. And then over x minus 3, x minus 3's will cancel out. And then we'll have the limit. Oops, all right, let's move it back over. As x approaches 3 of x plus 3, of x plus 3. So then I can just go ahead and substitute directly a 3 in for x. So then we'll get 3 plus 3, which is 6. Okay, so if we were to try another one, let's say our second example has something almost similar. X approaches 3, the limit of it as x approaches 3 of x squared. Let's say x squared plus 3x minus 18 all over x minus 3. All right, so again, it's x squared plus 3x minus 18 all divided by x minus 3. All right, so in this one, again, if you were to do direct substitution, in the denominator, it looks like it's going to be 3 minus 3, which is 0. In the numerator, we'll have 3 squared, which is 9, plus 3 times 3, which is 9. That makes 18 minus 18. So again, we'll have that indeterminate form of 0 over 0. So what you would need to do is go ahead and factor that numerator. So that numerator is a trinomial. That's a easily factored 1, right? Because the trinomial's leading coefficient is a 1. So you can make two sets of parentheses, put an x in both, and then we'll just say, okay, what times what makes 18? And the same two numbers have to add or subtract to make that 3. So I would say 6 and 3, right? 6 and 3 make 18, and 6 and 3, if you subtract them, will get you that 3. Now we just have to get our signs correct. So it has to be positive 6, negative 3. And that's over x minus 3. They cancel. And then you just have the limit as x approaches 3 of x plus 6. So just substituting in 3 now for 3 plus 6. we get 9. All right. So let's try another one that might challenge us a little bit more. Let's say we have the limit as x this time approaches 9 of the square root of x minus 3 over x minus 9. All right, so in this situation, it looks like if we try direct substitution, right, we're going to plug in 9 for x, you'll get a 0 in the denominator. If you plug in a 9 for x in the numerator, you'll get the square root of 9, which is 3, minus 3, which is 0. Again, you get that indeterminate form of 0 over 0. So in looking at this, nothing really to factor here. So what we're going to do, first I'll write it over. The limit as x approaches 9, square root of x minus 3, square root of x minus 3 over x minus 9. What we'll do is multiply the top and the bottom by the conjugate of the square root of x minus 3. So the conjugate of the square root of x minus 3 is the square root of x plus 3. So we'll multiply the top and the bottom, the numerator and denominator, by the square root of x plus 3. All right, and doing that multiplication, you would see that, okay, you would need to go ahead and FOIL this, right? It's a binomial times a binomial. But to me, I see one is the square root of x minus 3, and one is the square root of x plus 3. So that kind of gives me a hint that I can rewrite this as x minus 9, right? Because of that plus and the minus in each one, I know those middle two terms are going to actually zero out. So the square root of x times the square root of x is the square root of x squared. The square root of x squared is just x. 3 times 3 gives me the 9. That bottom part, I'll go ahead and write that out. X times the square root of x, and then x times 3 is 3x. Negative 9 times the square root of x is negative 9 square root of x, just as it's seen. And negative 9 times 3 is negative 27. Okay, so then we still have x minus 9. We still have the x minus 9 in the numerator. Nothing can happen with that. But looking at the denominator, we can kind of factor by grouping, right? Because it looks like I have the square root of x plus 3 that can come out. So let's take a look at it and you'll see it. So you have x times the square root of x plus 3. Square root of x plus 3. Makes this a little bit longer. Minus 9 times the square root of x plus 3. All right? So you see how we have the x and then the minus 9 and then the square root of x plus 3. See how all that comes out, because that's like GCF. If you do some factoring by grouping in this denominator right there, you should get what we got right there. So make sure you're understanding your factoring techniques, factoring trinomials, factoring by grouping, and such. So now what we'll have is x minus 9. And then within the factoring by grouping, when we see that occur, we're going to put the x minus 9, these two together, and then the square root of x plus 3. We need to just write that once because that's just like our GCF. So the x minus 9s get canceled out. When things cancel, they leave 1s, by the way. So then we're back to the limit as x approaches 9 of 1 over the square root of x plus 3. And now we can go ahead and substitute. So if we substitute 9 in for x, we'll have the square root of 9 plus 3. So the square root of 9 is 3, so that's 3 plus 3 is 6. All right, so that's just a couple of basic problems that we wanted to look at with finding limits.